So, good morning, everybody. It's my big pleasure and an honor to welcome you to the first Embedded World North America event. My name is Axel Sikora. I have the pleasure to serve as chairman of this conference, but also to the home conference back in Nuremberg in Germany, where we had in this year the 22nd edition of Embedded World. I've been there since the second edition, and it's a great pleasure now to become Embedded Worldwide. After 2 editions in Shanghai last year, this year, it's the first time in the US. Will not be the last time. You already saw the placards for next year in November in Anaheim in California. Embedded World for the last years has developed tremendously. It's the biggest event on the topic. It's an event which combines exhibition that you saw and a conference with deep technical knowledge. It's from engineers for engineers. It's not so much about marketing and blah, blah, but it really will go and shall go into the deep ingredients of the complete embedded scope. And in doing so, we are very happy to have also so many community partners from different associations, foundations, and of course the company partners who support us significantly. Obviously, Embedded World is changing rapidly, tremendously. If you look back for the last decades, starting from very tiny, simple microcontrollers into a world which is edge AI driven, which goes into a continuum between edge and cloud, fog computing, and stuff. And we believe that we also see so much interest here because there is a gap in this exchange, in this connection, in this required connection of the embedded community, or better to say, of the embedded communities, because there are so many disciplines nowadays that we want to bring together from topic directions, but also in the global world. Of course, such an event would not have been possible with the support of all the different partners, of the organizers, from Nuremberg Messe team, from the media partners, from the community partners, and a big thank you, of course, to all of you for being here for this event. After this keynote, of course, the exhibition hall will be open, and we'll have the conference tracks, 3 parallel tracks in the ballrooms B and upstairs in 5 and 6. And also we will have 5 panel discussions on important topics for the next 3 days. But I don't want to take too much of your time before a very special highlight of this event, which is the keynote of day 1. And as you might have seen, we have neighbors just down the road who are supporting us here, which is both the CEO and the CTO of Silicon Labs, and I believe this is kind of unique that we brought, or that they brought and offered us both key persons of the company. And first, Matt Johnson, the CEO of Silicon Labs, will start the presentation of navigating the future, technological breakpoints, reshaping embedded systems by 2035. An outlook into the future, what will be the challenges, what will be possible solutions, how to prepare for that. Matt serves as president and CEO of Silicon Labs. He, before becoming CEO, led the company's IoT business unit through a period of accelerating growth and industry leadership. Before joining Silicon Labs, Matt held leadership positions at NXP, Freescale, and Fairchild Semiconductor. He holds a BS in electrical engineering technology from the University of Maine and has completed executive programs at Harvard Business School and Stanford University. Matt currently serves on the boards of Dell Children's Medical Center Foundation, the Global Semiconductor Alliance, and Semiconductor Industry Association, the SIA. And as a second speaker who will join after a few minutes, we also have Daniel Cooley, who is serving as CTO and Senior Vice President, Technology and Product Development at Scilabs. I also should mention that Daniel had the keynote in Nuremberg 2 years ago, and we were so much fun that we re-invited him to talk in his backyard, or better to say, to invite him to his backyard. And as CTO, he is responsible for the company's overall research and development strategy and execution. He has a long Silicon Labs history, 20 plus years, where he started as senior design manager, holds a BS in electrical engineering from the University of Texas at Austin, has an MS in electrical engineering from Stanford, holds several patents, is also a member of Open Hardware Group board, and amongst many other roles is also a board member of the Austin Symphony Orchestra, which I appreciate very much as a lover of classical music. So, long words. The stage, of course, is to Matt and Daniel. So, Matt, please come to the stage and give us an outlook into the future of 2035 with Silicon Labs and the embedded world. Thank you.
Thank you for that warm welcome. And everyone, welcome to Embedded World North America. My name is Matt Johnson, and I'm the president and CEO of Silicon Labs. We're honored that Silicon Labs is delivering the first ever Embedded World keynote in North America. With Embedded World coming to the US, it underscores the importance and growth of the embedded community globally as well as locally. It's especially meaningful that we're here today in Austin, Texas, our hometown and headquarters for nearly 30 years. Silicon Labs is an innovator and leader in embedded development. The embedded space is increasingly going wireless, and embedded wireless is what we do as a company. That's why we're so excited about this event. I'm proud to say we are now the world's largest company dedicated to IoT wireless. And as a result, we have already shipped billions and billions of products to tens of thousands of customers in this space. In fact, we divested everything unrelated to IoT wireless so we could hyper-focus on this incredible opportunity that Daniel and I will be talking about here today. Simply said, we've been at the forefront of driving critical wireless advancements for a long time, and our breadth, depth, and focus on embedded connectivity are truly unparalleled. So let's talk about embedded systems and the Internet of Things. Everyone here has an incredible opportunity in front of them. We all now know that the world runs on silicon. And by 2050, the Earth's population is projected to reach an astounding 10 billion people. Growth that is driving unprecedented trends in economics, society, the environment, and technology. These are all incredible challenges, but they're also catalysts for incredible innovation and progress. And this is also true in our world of connectivity. Today's application developers have more reasons every day to connect to everything they can. Not just phones and computers, but also the embedded systems that are all around us. As we look forward to a future with over 100 billion connected devices in the next decade, it's clear that we're entering a new era. These connected devices will touch virtually every aspect of our societies, economies, and revolutionize industries that are all around us, like manufacturing, retail, transportation, healthcare, and agriculture. If anyone here is familiar with Metcalfe's law, you know that it tells us that the value of a network increases exponentially with the number of devices that are connected to it. This means that the impact of those 100 billion devices will be far greater than the sum of their parts, unlocking incredible capabilities, including boosting productivity, increasing innovation, and enabling capabilities that we haven't even dreamed of yet. It's incredibly exciting. So we're often asked, especially recently with post-pandemic and this most recent market cycle that we've all gone through, what do we think the IoT looks like on the other side of this cycle? Is it growing faster, slower? What does it look like? And the answer is, we believe that the potential for embedded IoT adoption is greater than it ever has been in the history of this space. And there's a few reasons for that, so let me walk through a few of them. The first is that the maturity of the underlying technology and the reliability of that technology is now at a level that enables broad adoption. You have to be able to depend on the robustness and quality of that platform. The next reason is that customers are now seeing great returns on investment in business models by adopting this technology. There was a point in time, I think, where people were finding solutions that people didn't even know they had a problem for, right? But now we're seeing great returns and great business models that are driving really fast adoption. Think of healthcare or electronic shelf labels. Additionally, we have the potential of capabilities like Matter or Amazon Sidewalk, which are considerable industry accomplishments in themselves if you think about what they represent. But you have to remember that they were all fundamentally created to enable broader proliferation and adoption of connected devices. That is ultimately why they exist. So that will help over time as well. But finally, a trend that honestly could be the biggest of all of our lifetimes is artificial intelligence. And it's certainly not something we can ignore in the embedded space or in the IoT space, particularly the symbiotic relationship between AI and the IoT. So before I start talking about this, maybe a quick public service announcement. You're going to hear us mentioning, between Daniel and I, artificial intelligence many times. But what we're not doing up here is trying to rebrand ourselves as an artificial intelligence company or saying that we've changed our strategy as a company. Our strategy in focusing on embedded IoT wireless is unchanged, full stop. What we see in artificial intelligence is a catalyst for accelerating growth and accelerating the adoption of embedded IoT devices. And at the same time, it will also allow us to accelerate our position within the IoT. So I'll talk about why we believe this, because I know these are big statements. So the first reason is that AI can help make the IoT smarter. Since the IoT was first defined as a term, we've heard about smart everything, right? Smart buildings, smart homes, smart cities, smart everything. But in reality, a lot of these things are connected, and they're not as smart as we wanted them or needed them to be. And this is in part because they didn't work well together as a cohesive, intelligent system as well as they could or should. This is often because they're lacking in the contextual awareness, natural interfaces, and meta-intelligence beyond the individual sensors and devices. AI will change that. It will help these connected devices become a lot more useful and impactful in fulfilling that original promise of the IoT, a truly smart and intelligent IoT. The second reason is data. The sheer volume of data that is already being produced is staggering and virtually impossible to manage without the intervention of AI. This often unstructured data can help produce real-time insights, predictions, and intelligence that has never been before so readily available to us and wouldn't be possible without artificial intelligence. More importantly, not only does AI bring the ability to take advantage of existing data, but the need for more data will be insatiable, driving the need for more devices and more connectivity than previously thought possible or imagined. So a bigger IoT than ever before. And the third reason is that AI inference will take place at the edge. We will see AI inference, machine learning, and other types of AI taking place at the embedded edge that we all live in. AI processing does not only take place in data centers. And over time, you'll see that that embedded edge that we all represent here in the room becomes a perfect spot for inference, and that is the future that we see. So this all sounds awesome, but in reality, there's a lot that's needed for these things to be realized, and it's impossible for us to do it alone. So Daniel will join us here in a few minutes to talk about some of the innovations that will help drive this acceleration. But before we do, I want to talk a little bit about the regulatory environment and how that environment is waking up to our growing embedded universe. The last few years have marked an unprecedented government recognition globally of the criticality of semiconductors. Remember I said earlier, the world runs on semiconductors, and the world now realizes this, maybe for the first time. That's driving massive investment into the semiconductor space, hundreds of billions of dollars globally. Nationally, right here in the US CHIPS Act, with its more than $50 billion of investment, and the ITC, or the Investment Tax Credit for manufacturing, really marked a historic investment in semiconductors by the US government. And since we're here in Texas, the Texas CHIPS Act builds on the federal initiative by providing both support for manufacturing and design, addressing the gap for fabless companies like ours, which was not addressed in the US CHIPS Act. So this comprehensive approach fosters greater innovation in embedded systems. And I'm proud to announce that Silicon Labs has been awarded a grant to accelerate our chip design efforts, strengthening our global leadership as well as our position as the largest wireless R&D center in Texas. But it's not only about the funding. Earlier this year, the FCC also approved the US Cyber Trust Mark consumer IoT devices, for IoT devices. The marks framework was developed by the CSA in close collaboration with many IoT designers and suppliers, including Silicon Labs. The goal of the mark is to create a living label on consumer IoT devices that can give them the confidence that their device is secure from the latest cybersecurity threats. Think of it like an Energy Star label on appliances. It follows similar efforts from around the world, like Singapore's cybersecurity labeling scheme, Europe's radio equipment directive, and these are all to protect not only consumer data, but also to set a level playing field for device manufacturers to help build trust and help grow the overall IoT. And as everyone here knows, in a lot of cases painfully well, cybersecurity moves incredibly fast. Quantum computing is more and more real. Just in August, NIST finalized its first set of quantum encryption standards. And while the average cyber criminal won't have a quantum computer at their disposal, malicious state actors will. And they could use this incredible capability to cause massive disruptions for our space, our industry, and the countries as a whole. So why is all this important? Well, as we discussed, the world has recognized the importance of silicon and silicon's role as the modern backbone of societies and economies. And these investments and regulations are powering a new era for the embedded industry. They provide the funding and framework for secure, innovative, and scalable solutions, moving us forward in the connected device space. By actively engaging in these efforts and aligning them with our goals, we can drive the innovation faster, build trust, increase security, and ensure a stronger and more connected future. Simply said, y'all, we can't stand on the sidelines and watch these things happen. We have to take an active role in them. So in closing, I want to emphasize how critical our collective involvement in helping steer the industry has become, and how even more critical AI and product security will become in our embedded systems and IoT landscape of the future. Our commitment to these principles is evident in our current industry-leading Series 2 wireless platform, which is custom-built for embedded wireless, not repurposed IP. Because of this, Series 2 has led the industry in each category, whether it's power consumption, multi-protocol wireless performance, device security, and battery-powered machine learning inference at the edge. In fact, we were the first company to bring a dedicated ML accelerator to a wireless SoC. We were the first company to bring PSA 3 level security to any of these products. And building on this success, our next generation platform, Series 3, is being built for a future where inference at the embedded edge is powerful and pervasive. A future where device-level security supports post-quantum encryption. And where, of course, once again, we introduce new-to-industry wireless performance and battery life. To share more about this, I'd like to welcome Silicon Labs CTO Daniel Cooley to the stage. And now, I'd like to welcome Daniel. Thank you. Congratulations.
Guten Tag. Oh, wait. I'm used to this being in Germany. Where's Axel? There he is. I guess we should say howdy, shouldn't we? No, in all seriousness, a couple years ago, I was like, when are you coming to the US? You know, we have a lot of embedded stuff going on, especially on the semi side, and it'd be great to see that. And here we are today. I'm thrilled about it. I think it's all important we do our part and support events like this. It can't all be CES, although that's great too for some things, or an automotive show. I think, you know, we are the embedded community, and we need to support that. So heading into it, you know, Matt talked a lot about the IoT and data. And I gotta just say, one of the fundamental reasons why IoT devices are more valuable than non-connected devices is because you can shuttle that data off and on those devices at will. You can do it cheaply, you can do it reliably, you can do it quickly. And that just wasn't the case 10 years ago. The result of that is that the data being generated by internet-connected devices is increasing exponentially. Next year alone, the total volume of data generated by internet-connected devices is expected to be 80 zettabytes. That's 80 trillion gigabytes. And I remember when a gig was like a big deal for us, and maybe I'm dating myself a bit, but this is 80 trillion of those things being generated every year, and it's just going up. And we're all part of this big ecosystem, generating, processing, transmitting, storing, securing that data. And how we use it's really gonna be the key to how big and this is gonna be in kind of the overall economic impact. We'll come back to that in a minute. First, we gotta talk about where this data is even coming from. How do you get to 80 zettabytes? Well, the growth is driven by a lot of factors. Explosion in connected devices, transformation of industries, social media usage, expansion of e-commerce, digitization of services, everything you can think. Every click, every swipe, every vibration, every temperature change, every badge in is another data point contributing to this big, vast ocean of data that holds all that potential. You know, going forward, the barrier to actually accessing and using this data is so low that it's really up to our imagination on what we do with it. Things that were once completely unthinkable, or at least couldn't be envisioned to make money on it, are now at our fingertips. And I have an example I want to share with you on that. My grandfather, he graduated from the University of Kansas in 1950, you know, really post-World War II, and spent the next 60 years of his career building power plants and power distribution systems in the US and in Asia. And late in his career, early 2010s, I asked him, you know, what his thoughts were about this smart grid. Scilabs was getting into this IoT business, and I felt like it was going to be big, and I was like, I need to talk to somebody who's actually, you know, been there, done that. You know, and he said the success or failure of this thing was going to be down to two things primarily. First, the ability to reliably, securely access the data whenever you need it, down to the grid. Down to the grid, down to the meter, all the way down to the endpoint that the power systems can see. And then, of course, to secure that system end to end. And this made him nervous. Lives were on the line. You know, he knows what can happen when power systems go down. For a consumer, it might be a minor inconvenience, but if you're a fab, as we learned in 2020 here in Austin, you know, it's a lot more dire. You know, but he also acknowledged that things were pretty optimized in the power space, that they had figured that all out in the 50s and 60s, and that to take that next step, you really had to get access to real-time data all the way down at the end. So it all comes down to this data and trust. It's not surprising, right? But sifting through it all is a pretty big task. People cannot do it. I don't want to be signing up to go through those 80 zettabytes of data, and I don't know anyone in the room here is. There's just too much, and we're going to have to take advantage of, ta-da, machine learning and AI. And I know that's the kitschy buzzword that every keynote and everybody is sitting up there in the industry saying, but it's true in the IoT. Unfortunately for Scilabs, and I think for the embedded space in general, we've been thinking about that for a long time. We've known there's valuable data out there, and we've been trying to apply tools. We just now have a new tool for that. And it's still early days for AI and the IoT, but I like to say that machine learning today is where wireless was 10 years ago. We know it's coming, it's on the horizon, and it's going to be a really big deal. And we'll talk more about that in a sec. But I'd like to kind of build that story out for a second by talking about some of the other technologies and how they've contributed to embedded systems, and then the AI piece just is kind of the next step, really. It's not a big stretch. So the four we're going to go through is connectivity, compute, security, and finally machine learning. And you can't get to that last piece until you understand how the first three have evolved, and we'll talk about the step that all of them are going to take in the next 5 years and the way that you need to use these systems. So first, connectivity, kind of the root of Scilabs and why we're here at the table. At the core, this is about one thing, breaking the air gap. Historically, embedded has been around a long time, very long time, but it was air-gapped, and now it's not. And connecting the devices together and to the internet is a pretty transformative effort. This was the basic thinking behind early versions of the IoT. Identify the areas where connectivity is needed and connect them. It's pretty simple, and there are a lot of ways to do it. But the reality is that most embedded systems fall into three categories. There's personal area networks, local area networks, and wide area networks. The personal area network, if you don't know what that is, it really connects two devices, one-to-one, pretty low data rate, low power, short range. This is like an example of that that's really relevant today is glucose meters that might be reading for diabetic care and connecting to your phone. That's a personal area network. Local area network connects many devices together, but in a kind of tight area. Maybe not as narrow as short range personal area network, but like in this room, the lighting network here, or a network of shelf labels. You saw the image from Matt's presentation in a store. And finally, the wide area network is what it sounds like. It's a very extended range that can go miles or tens of miles even, and it can connect things like electric meters or asset tracking as things are in transit. So in these installations, you'll probably have one, two, or maybe all three of these kind of networks running simultaneously. An example of that is in agriculture. We're seeing a lot of technology adoption in agriculture, which frankly isn't new. The agriculture space was kind of one of the first ones to adopt a lot of technology because we were spending 95% of our collective capital and time growing food and trying to scrape a living. So it's not new. It's just now entering the silicon era. And you can see that if you stop by the John Deere booth at the next CES to see what I mean. Here in Texas, we have the US's largest working farm, the King Ranch, and it covers 825,000 acres. It's bigger than the state of Rhode Island, if you've been there. But that isn't the biggest out there, really. If you think about the Mudajiang, city mega farm in China, that's more like 22 million acres, 100,000 cattle. The only way to do this is with technology. And so the IoT offers the benefits of commercial agriculture, or to commercial agriculture, from irrigation monitoring to perimeter to tracking your livestock health and location, and a whole host of other things. So wireless is big, we got it. What's coming? Well, now that we've added that data pipe into all these embedded devices, you're starting to see the wireless get used for more things. So once it's there, you have the cost, leverage it, do everything you can with it. And I want to talk to you about some of the examples. Some of them you may be doing in your businesses, but there's a whole host of things that you can be thinking about. First is manufacturing, which we learned a heck of a lot about in the supply chain crisis, and thank God we're not there anymore. But wireless is now being used to kind of configure the product as it moves through the production line. This isn't just built-in self-test or secure key injection or something like that. They actually configure different wireless protocols as it goes through to program it, for example. So a lot of people are using this just-in-time programming model to hit it right at the end of the line. Or if they're really in a time crunch, they'll ship the product and then OTA firmware update it when it's installed in the field. That's a big deal. Now you have months of time potentially between when that device hits the dock until it's delivered in the store, and the software teams can keep cranking. Other companies are using wireless protocols to reconfigure devices in the field. This isn't an OTA update. This is changing the fundamental properties of the product itself. We're seeing that now as many legacy Zigbee installations are going to flip a switch and convert straight into Thread. Now we have IP-based Matter over Thread that can connect into a wider ecosystem. We're very excited about that. You can't do that without this wireless. Imagine if you had to go drive a truck, pull everything out, and put in the Matter stuff. This is a lot better. Another use case is for diagnostics. So the product out in the field is failing, and it needs to report back, and now it can. Or if it gets shipped back to the factory, you can very quickly figure out what the heck is going on with it in a non-destructive way, in a very safe way, in a low-cost way. No USB, no Ethernet needing to plug into this thing. As long as you can get power to it, you can probably figure out what the heck is going on. It's just better. There's even more use cases coming, y'all. Wireless power delivery. People have been working on that for a very long time, and in RFID and those kind of wireless technologies, it is there, but people are trying to now step it down and do more with it, eliminating out of batteries out in the world, and that's a big thing, especially in Europe. We're also seeing things like wireless sensing, so ML, machine learning applied to wireless, taking pictures wirelessly to figure out all kinds of stuff. So these are the kind of things that people are going to be doing over the next few years in that wireless. They've worked very hard to add that critical data pipe. They figured out the mobile app or the cloud behind it, and now they're cycling back through and doing more with it. So that's the wireless piece. We're going to move to compute. So the embedded applications today are doing more than ever before, and y'all know that because you're building them. And the compute has got to keep up in every way. It's raw, MIPS, core mark, however you want to measure it. It's the memory. It's the peripheral access. I mean, it's amazing when we look at some of the schematic diagrams of our customers now, and what's a very simple product, you might have 200 GPIO running on one of these chips. I mean, this is doing a lot. These things used to be just simple air-gapped devices, and now they're not. That means you have to keep up with the standards, security patching, in-field update, firmware updates, and even more. And so these things are going through generations. Gen 1 of a product was pretty simple. Add that Bluetooth connection, add that Wi-Fi connection, add some wireless connection, but really leave the rest of the system unchanged. Gen 2 was, okay, now we've been playing with this thing, we can see it from the cloud, we know what to do with it, and man, we need to add some more sensors down there, because now we can see this real time. We can do more stuff with it. Gen 3 is going to be even different. You're going to have to redesign again for machine learning. So we'll get to there in a second after we talk about security, but the ML thing is going to change a lot in about half the applications out there. Half won't get changed. A wirelessly connected exit sign won't add ML. A wirelessly connected door sensor probably won't, but there's a ton of applications that will. So the application now is getting harder and harder to develop. You can't do it on bare metal anymore. A couple years ago, actually, you might remember, or some of you who were in the room, I made a big plea, please adopt real-time operating systems, and that's as true today as it was back then. You can't scale IoT applications on bare metal, and you certainly have a tough time connecting them into the cloud applications. It's not built bare metal to OS, Linux in the cloud. It's really got to be OS to OS, and if you're not doing that, if you're not adopting something, there's lots to choose from. There's Zephyr, there's FreeRTOS, there's more. Please go do that. You are falling behind, and trust me, you will ship faster if you're adopting real-time operating systems. So I'm a chip guy. I'm a hardware engineer. I'm an RF designer by trade, and I'm also up here saying, please, for the love of God, go get modern on your software. The chips are capable of this now. The overhead that you think may be there is not. So to really scale the design, to really move fast, you're going to have to adopt those operating systems. And the winners are really being teased out in the next few years. You're starting to see products come into the market at new nodes, like 22 nanometers, with like really built from the ground up for real-time operating systems. So please go do that. Third, let's talk about security. Near and dear to my heart. We were one of the first companies to really go deep, down to the silicon, down to the transistors, and invest in this space. And we're finally seeing it's really a top priority for the whole ecosystem. You know, Matt was referencing some pieces that I'll talk about in a minute, but as a group, as an industry, we've been grappling with this for the better part of a decade, and we're not done. You know, there's a lot of factors to consider in security: key storage, identity management, code scanning on your software. S-bombs is coming up now. And the attackers are getting very sophisticated, both remote and local attacks. And yes, they are too applying machine learning into this. And we've got to step up our game. And I'm pleased that real action is underway. You see it in the government, the governments, the standards alliances, the standards bodies, the silicon providers. We're all coming out with great technology, but these initiatives take time to play out. I'm just glad they're going in the right direction. We felt it a long time ago. We're seeing the action now. We're actually seeing customers as a primary or secondary decision factor in their entire product asking the security questions. It's not just the compute piece or the wireless connectivity piece anymore. So these air-gap devices, the old stuff doesn't really need it as much, but the internet-connected ones do. And it feels like climbing a mountain, and getting to that summit can, take forever, and there's hundreds or thousands of steps along the way. A lot of primitives and processes you have to put in place, but we're committed to making it happen. And once you have it, you have proper lifecycle management, and that's really the foundation for a scalable IoT. We take this responsibility seriously. Without serious engineering behind it, I really truly believe the whole thing will fall like a house of cards. So you want to protect your data, your IP, all that privacy flowing through the networks. Please continue to adopt that technology. You're seeing more and more silicon companies coming to the table with it. Hopefully we're doing our job making it as easy as possible to use it, but we always want your feedback when you get there. So, Matt talked about governments and cyber trust marks and post-quantum encryption. Yeah, we're talking about post-quantum now, even embedded, y'all. Please just ask, read, do whatever you have to do to stay up to date with what's there. This is not going to be a one-and-done check mark. It's really going to be a continuous process from now until 100 years from now. Moving on into machine learning. And I promise all of these are coupled, and there's a very simple example at the end. ML is going to be big in embedded, and we've known that for a while. And the use cases have always been around. So, we've seen that back when we were selling MCUs. Our customers were, even then, on little 8-bit or simple 32-bit micros, trying to do things like grass break detection, and but not doing it very well. Okay, so look, the IoT needs machine learning. If y'all can move on. Sorry, there's a screen back there trying to prompt me. We've always seen the need out there. We just didn't have great tools for it. We didn't have great accelerators for it, and frankly, ML was in the kind of one of those freeze eras. So now we're coming to the table with this technology. Now we're bringing dedicated machine learning into the IoT, not just in the cloud, not just in mobile. Everyone thinks GPU is the only way to do ML, but that's really not the case. And you can get a lot done without buying a $50,000 GPU and plugging a power plant or whatever you have to do to power the dang thing. There's a lot of applications for inference, and there's as many as sensors in existence. It goes a long way past facial recognition on a camera or a wake word detection in a security system. We're talking about almost any sensor. It's temperature, pressure, light, vibration, audio, image, whatever you can really imagine. They're all candidates for machine learning, and now you have a way to actually find what you're looking for. You've always been looking for something, and now you can find it. Maybe it's the number of people in a restaurant or in a room like this for the fire marshal. Maybe it's a gunshot detector on a city corner trying to figure out if it's a gunshot or a car crash. Or maybe it's a signature of an electric vehicle being plugged into an electric meter. The utilities really want to know that so those transformers don't blow up when a car starts sucking thousands of amps. Maybe it's a pump in an espresso machine, which I couldn't find here at this conference. At Starbucks, before that thing goes down. They don't want that thing to go down. So we've been launching products with this actually for years. We have in our XG24 family. You no longer really have to sacrifice cost or power or latency to find these kind of signatures. You're not going to do LLMs on our chips, sorry to say, but you can do this stuff. Our matrix vector processor, for example, is leading in the market on this latency, power, on multiple kind of algorithms on ciphers. You can go check it out. It's ML Commons, the ML Perf Tiny. It's right there on the site, or better yet, you can buy a kit and just get started. We've got a lot of examples. So to take that to the next level, okay, we have to step function the ability for these devices to be smarter. And I truly believe processing this data locally is going to be big. And once you fine-tune your machine learning algorithms out in the cloud, paid millions of dollars, got your data from somewhere, you put it in a device, and you won't necessarily need to transmit all that raw data anymore. The end product is going to act, or transmit maybe the action instead of the raw data. And that's good for a lot of reasons. It extends the battery life, first of all. Radios are expensive from a power perspective. It also preserves the spectral efficiency. I mean, there's one resource we can't make more of, and that's the spectrum itself. And it's getting crowded, y'all. There's a whole bunch of other benefits. Keeping the data locally, it's private, consumers like it. You don't actually have to bring it into the cloud to store it and process it, and any liability associated with that. And liability is a big deal. You want the action, not the raw data sometimes. This is really where it's been going all along. And companies who are going to be the best at this are also the ones who are deploying it the most. There's a positive feedback loop that builds up. You train your algorithm in the cloud. Right? You have millions of devices in the field. Now you're collecting data, and you're starting to see what they're seeing, okay? And then you find edge cases. And this is where the algorithms or maybe the initial training data set don't work. So you find those edge cases on the device. The device itself will be able to flag an instance where maybe the algorithm's not resolving perfectly. Maybe it's only 80%, 70%, 60% sure of what it's seeing. That's a really interesting data point. You tag it, you pipe it back into the cloud, you use it in your next training round. Now you have new weights. Send it back down to the device. And please don't tell me you can do this without that security, by the way. I don't think anybody's going to spend millions and millions of dollars training data in the cloud and send it down to a fairly cheap, $1, $2, $3 chip just for somebody to swipe. And that's, again, where it's been going all along. I think that's very key to making things smart, as Matt was saying. Once these things are talking together, once you have your IoT devices in the field, interacting with them, being intelligent instead of raw data pipes, this is when a lot of the economic value is going to accumulate at the highest levels in the economy. This is where you're starting to see really the lever that we've been talking about in the IoT take shape. So what's next? Well, last year at our annual developers conference, it's called Works With, we told the audience a little bit about our next generation of products. So Matt was talking about Series 2 and 3. I'm going to expand on that a bit. And Series 3 it's really our 4th generation. There was a Series 0 there, but we don't talk about that one. But today I want to do a little show and tell. Actually, I've got it here in my pocket, if the camera can come up. Here. Zoom in. Oh, I promise it's there. There it is. There she is. This is our first piece of Series 3 silicon. It's a big deal. It's a badass product, and there's many more that are coming. And this is not a product launch, okay? This is an industry keynote. But there's nothing like it. And there's nothing like it coming in the future from other companies. And I'm showing it as really a proof point about everything I spoke about just now. Those 4 key components: connectivity, compute, security, machine learning, intelligence. This kind of product pushes state-of-the-art on all 4 of those vectors. And we're not doing it for mobile or PC or even dedicated audio. It's really for embedded systems. It's got the best M-class memory architecture for embedded systems. It's got the best secure interface for embedded systems. It's got the best flexible modem, so you can ping-pong between these networks really quickly and hit the right packet at the right time, all in hardware, for embedded systems. It's got machine learning for embedded systems. Our market is big. It's grown to the point now where we have dedicated technology coming in. Series 3 is going to be that. It's really what's going to take the IoT into the smart era. Not just the connected era, the smart era. Other companies are going to come to the table too. This is not just Silicon Labs. We all see it. And I encourage you guys to adopt the technology as fast as you can. I think the more we do this, the more the value prop for the IoT really plays out. So The embedded markets have grown to the point where we warrant it, and now we're driving state-of-the-art in multiple areas, again, not borrowing, security from PCs or something like that, like we did in the past. So y'all hold the key to driving the next generation of devices. I truly believe these markets can improve the economy, can improve our lives, build smarter world, more secure world, really, as the data flows around. Today, we challenge you to take that leap, push state-of-the-art, come talk to us. So with that, I'd like to invite Matt back on the stage, and I think we're going to take some Q&A from the audience. Thank you.
Keynote. Very much appreciated to have this broad view on novel technologies and how to shape the future. As we said, we would like to have a little bit of Q&A. We are a little bit running late, but we should use the unique opportunity to ask questions and hear the answers. So if you have questions, please, there are microphones. Please come up and raise them. So if you're not moving, then I have to take the role. The title of your presentation was Reshaping Embedded Systems by 2035. So if we now would be in the 11th year of Embedded World North America, we will invite you again. Hopefully again to Austin once the convention center has been reshaped. What would be different in your keynote?
In terms of all things considered, or?
All things.
Sure. I think it's difficult to imagine, as we talked about in the presentation, as we go to more nodes, more connected devices, that creates possibilities and potentials that I think are difficult to even imagine. And at the same time, with AI moving at the speed that it's moving, that creates potential possibilities beyond that. So I do think you'll see this space look incredibly different in terms of the amount of devices that are out there and the impact those devices are having on our world and our day-to-day lives. It's exciting, but it also represents a lot of change. Daniel, anything to add?
I think it's real simple for me to add on to that. LLMs will be programming our chips, probably, at that point. I don't think humans will be down in that deep in the code anymore. And so I think the amount of data flowing will go up exponentially as the AIs decide what to put on devices and when to put them on. That's going to be interesting. The software cycles are going to accelerate so fast. I don't know how the chip vendors are going to keep up. Maybe we'll have LLMs building chips too.
A question, please.
Sure. Matt, Daniel, great job. Security has become very important to our IoT customers.
Yeah.
Silicon Labs is obviously a leader in this space. What do you see, and how does Silicon Labs enabling security for our embedded customers in the wireless space?
You want that?
Sure. In many ways, a great question, and yes, it's becoming more important. I think down in the hardware, you have to put root of trust. So there's a lot of primitives in security. We don't make a secure system, our customers do. We have to provide a lot of the pieces for them to do that. Down to the hardware, in the software, in the way we architect, even down to the architecture, even lower than the hardware, as we do things like our boot processes, our boot chains. And then we have to go through the work of certification. We have to show the world. We can't just say, trust us, it's secure, don't look behind the curtain. We have to really open it up. And we've done a great job on that on our software. I think that's really where there's a lot of open source now. We're putting more and more of our code into open source for that reason. And then we provide all of the certifications that we need for, ARM PSA or DTSEC or whatever government body is really asking for it. So there's a lot of ways to do it, but it needs to be thought through structurally, architecturally. It's not a last-minute feature add. It's not a feature at all. It really has to bleed its way through the processes in an organization.
I completely agree, and I'd just add, it's just kind of fascinating to watch it play out that, the devices that we make, they are out there 10 or 15 years easily. And, trying to anticipate what that's going to look like from a cyber security perspective that far out in time, And then putting that capability in these devices, a lot of times they come to market and people look at it and say, I'm not going to need that. But over time, you see the market move in that direction. So I think that's what happened with Series 2, and I think that's exactly what will happen with Series 3 as well.
Excellent, thank you.
Yes, please.
So kind of hand in hand with security, what's your strategy for safety and like safety critical systems and how to ensure that AIs don't kind of go off the guardrails?
Sure. I mean, there's only so much we can do at that level, at the device level. Where we, as a company, kind of draw the line is we do not get into safety critical systems, something that, in the automotive domain would be functional safety or ISO 26262, where, it's life critical. We don't go to that point today. Although, admittedly, we get asked to do that a lot. Currently, there's more opportunity than we can keep up with in the existing markets that we're in. But it is something we take very seriously, and we'll continue to support any initiatives out there and standards to do that, because it's a big concern, and I think it's becoming larger for our customers and even employees, to be honest.
Yeah, and just to add to that, there's a lot of ways to help safety and safety critical applications, maybe not to the degree of 26262, but we have customers who are now saying, wait, I want to buy your product and I want to run very safe code on it, like a switch. What's it called? Blanking on electrical switch. They want to run their code monitoring for a circuit breaker trip isolated from the code that's running the Bluetooth stack, as an example. So we architect our system with multiple CPUs so that we can help deliver that kind of thing. So, as you drive more CPUs up on a chip, as you have more RAM typically, this is where it shows up, and we're doing a lot of architectural things to make that as easy as possible so that when things fail, because they will, it's in a well-structured way.
Good point. All right, thank you.
Thank you. Next question, please.
Hi, thank you for the talk. So there was a mention of divesting out of everything that's not IoT wireless. Does that mean that all of the legacy USB UART bridges and those kinds of products are being discontinued?
Oh, great question. I apologize I wasn't clear. There's no future divestiture on the way. We love everything that we have, and we're going to keep it, including the USB UARTs. So that statement was about a few years ago. We divested everything unrelated to IoT wireless. So that's done. As part of that, we kept everything related to IoT and trying to really service this opportunity we've been talking about today.
Great, thank you.
Yep.
Hey, thanks. So Daniel, I really like the term you use. I think you use connected IoT moving to smart IoT. As a user that's really pervasive in the home of all my IoT devices, I'm waiting for them to be smart. My question is, there's a lot of concern from people about IA and artificial intelligence, What do you think that's going to do to consumers as this starts to happen? Is there going to be blowback? Are they going to be concerned about deploying these devices that have artificial intelligence in their homes?
I think many of them already are. Yeah. There's as many people that are comfortable with AI as they're afraid of AI, frankly, today. But I do see it going one direction over time. And in my kids, they're not afraid of it. And younger generation's not afraid of it. The same way that an older generation might be afraid of putting things on Facebook. Why? Because why would you do that? The younger generation's like, why wouldn't you put it on TikTok or Facebook or Instagram? And I think over time, consumers will adopt this stuff because it does make certain things easier. Or if it doesn't, then it won't. I mean, simple as that.
But let's ask.
Yeah.
Just curious, this audience, which predominantly should represent early adopters, I would think. Let's just say, just for fun, that there's an autonomous helper robot that's available to purchase, be in your home, and get work done. That is, the intelligence comes from artificial intelligence. How many people would purchase that? And put that in their homes?
Yeah.
Okay, and how many people would say not the first or second generation? Yeah, okay. So it's kind of fascinating, right? Because I think, Brian, to your point, that kind of gives an indication. Okay. Other questions?
Yes, please. Maybe you can go to the microphone.
Or just go ahead, we'll repeat it. Don't worry, I got you.
No, rather go to the microphone, please.
I guess the biggest question for me is, what's the biggest challenge facing your business right now?
Current market cycle aside, which that's been a blast, but putting that aside, big picture, it's scaling and keeping up with it, truly. If we look at it, we're talking about numbers that are, kind of incomprehensible. Billions and billions of products shipped, billions of devices out there, and if we look at it, there's no shortage of opportunity. But wireless has always been, a relatively high touch space. And, to find ways to give the customers the support and experience they want as they do go down this path, and add in addition to wireless, very complex security, machine learning, all these things, and make it so customers can do that as efficiently and productively as possible. And because if every customer needs high touch, not only will it be a challenge for us as a company, it's a challenge for the entire industry, and we don't get there. So we see that problem as one and the same. Solving that, which is what we invest almost everything towards, is a win for the industry, it's a win for us. And we're making great progress. I don't think there's any company in the world that has more wireless technologies that service a mass market than we do. But we're still not there. There's still a lot of opportunity and potential. So that's it, is that scaling and helping the market go and grow faster.
Excellent, thanks.
Yep.
Good morning. Good to see you guys, Matt and Dan. Quick question for you. You talked a bit about cybersecurity regulation, and that's one part of it when you have malice third parties, both domestic and international. But when you look at AI laws, fundamentally, it's privacy laws.
Yeah.
And that's been so pervasive in our industry, but that's a new aspect of regulation and law. How are you seeing those privacy AI laws coming down to you as a silicon vendor, but just overall the industry?
That's a softball one. Go ahead.
I mean, so there's multiple layers to the technology stack. Everything from data center to gateway infrastructure, call it, even your mobile phone can be considered that sometimes, all the way down to these far-end nodes. We are at those far-end nodes. That's Silicon Labs. Like, far edge is what I tell people. I'm usually like, nope, one step further than that, and that's where we live. So far, it hasn't hit us hard, but I think it's going to be coming. And I think it will come when you start having to ask questions about how the AI made its decision. Mm-hmm. If a security system tripped or didn't trip, and let's say it was a false negative instead of a false positive. Mm-hmm. So someone broke into your house, but the security system decided no one's in your house. How did it make that decision, and who's liable for this thing if you're using AI to help make that decision? I think that's where it will hit us, and this is where we will be the beneficiary of this policy being worked out in other markets, like automotive. They have to figure out when a car crashes, well, who's responsible, as an example. So, I'm watching very closely to see how it plays out there first before it really hits us. That's what I think is going to happen. I don't really hear it from our customers yet. And I think we're still at the early, like I said, year 1 of 10 kind of for AI in the IoT. I don't know if you want to add anything, Matt.
Yeah, the only thing I'd add is, like Daniel said, we're not seeing that yet. And if you wanted to be a little skeptical, I think that this is going to be a challenge, right? That regulation always struggles to keep up with industry and technology. And we all know that and see that in so many areas and places. And at the same time, I don't think we've seen something moving as fast as AI. Yeah. And AI is accelerating. So those two things don't work together, right? Regulation's already slow, and technology is moving even faster. So the likelihood that regulation will keep up is very low. And I think that that's going to create challenges as we move forward. It will try. And maybe we'll all be shocked and we'll see a transformation there. But I think it'll continue to move at an accelerated rate, and regulation will be running behind, trying to keep pace.
As it always does. Thank you so much, gentlemen.
Yes, please.
Yeah. Thank you for the informative talk. You mentioned encouraging everyone to move to RTOS and I get that helps with accelerating applications and getting the software up quickly. But are some of these RTOS systems, are they really capable of getting the speed to the point where where we're capable of doing it on the hardware itself, doing the bare metal? Thank you.
I mean, no, it's not, but I don't think it's necessary either. I mean, the chipsets themselves are also running on Moore's Law. And no, we're not doing 2 nanometer, NVIDIA chips paying $30,000 a wafer. But we are on our own progression here. So anything you might lose in terms of, I'm adopting an RTOS, you're probably getting net benefit on the next chip anyways. So, just like you run CUDA on NVIDIA GPUs, you're not getting the full performance out of the GPU, but you're running a hell of a lot faster than you ever could if you were trying to go bare metal on that GPU. The same thing is going to play out in embedded. It played out in PCs. It played out in mobile. I remember Symbian trying to get to be the big thing at Nokia, and finally we had a proper one with iOS and Android. It's coming. What I see from our customers, they spend like 95 or maybe 99% of their time in software development, maybe 1% of their time on the board, or an antenna issue, or a shielding kind of thing. 99%, 95 to 99%, correct me if I'm wrong, sales team, but speed that up. Don't worry about that 1% over there. And the only way to do that is with better tools, or code reuse, and that's operating systems.
Maybe I could add from my side.
Can I add one more quick thing? We will still preserve, of course, the ability to run bare metal on our products. You can do it today, you can do it in the future, and there are some applications like a motor control or something where you don't want to go with an OS. You can do that. We will have ways to bring your code and your algorithms from bare metal into the products without going into the OS. But for everything else, you do need to go to the OS.
Yeah.
Sorry.
Nevertheless, let me use the opportunity to invite you to the Mo's keynote speech from Kate Stewart from Linux Foundation. She's looking after the Zephyr OS project, and maybe this would be a very good place to re-ask the same question to her again. So this will be tomorrow at the same time here on the stage.
Hi, good morning. My name is Ashish. I came in from Silicon Valley. Thank you for your keynote. 10 years ago, when IoT was probably the biggest buzzword, everybody was doing IoT their own way. That came at a lot of customer inconvenience. Things were not interoperable. And today with Matter, it has been simplified. So can you please talk about some initiatives you are driving to create more standardization so that customers and devices can interoperate better?
Well, we should both answer that.
Thank you.
I can start if you want.
Yeah, let me just add one thing really quick. There's a few things that are worth mentioning. There's a need that is still not fully addressed out there in the world. And I think solutions like Matter are going to help and are assisting the industry, and that's very important. And that's why we've leaned into doing everything we can as a company to helping Matter be successful. I also think there's a misunderstanding out there that, for all of you who've been in the space for a while, people always asking, when does this go away? When does that go away? And as a general rule, they don't go away. They just keep adding new things. So that's come at an incredible tax for us as a company to continue supporting everything and, not cutting branches off for our customers on technologies that they've designed in. So, where we see things going is, yes, there's some protocols and technologies and ecosystems that have gained some critical mass, but we still think it's important to support all the technologies because increasingly, when we go to a customer, they're not asking for one wireless technology or ecosystem. They're asking for multiple technologies and multiple ecosystems because that's what they need to support. So, the reason I bring that up, I think the world continues to get more complicated, not easier to do these things, but all of these things will help, and I think it's critical that we keep pushing on this. If the IoT is going to reach its full potential, even though it's very different than 10 years ago, I think it's going to be even more different a decade from now to our earlier discussion.
I'll just add 2 things to that, kind of concretely. First, open source software, I think, is a big part of our future. We've all been moving to the common standards, that we can agree on, but I think the next step is to go to as much open source code as we can. I think that will have a tremendous amount of reuse and speeding things up and just driving a consensus much faster than a proprietary or closed source model. That's one thing. And I'm finally starting to see the other ecosystems think IoT. We see Apple adding Thread to their products. as an example. That's a really indication that this thread is not any other protocol except an IoT protocol, frankly, and here they are adding that everywhere. You're seeing other indications like the Wi-Fi Alliance. In Wi-Fi 6 and 7 and 8, they're taking big steps forward for dense networks that aren't necessarily high bandwidth. That's IoT. So you see dedicated features coming into these where Wi-Fi once was driven only by one thing, really PCs and then mobile. And here they are now saying, no, we're going to talk about quality of service and reliability and target wait times and BSS coloring and all those kind of things. So pushing that is, I'm seeing, we're doing everything we can to push these kind of initiatives, including put our own code into open source.
Thanks very much. I would love to continue the conversation.
Yeah.
Hello, thanks for the presentation. I'd like to piggyback off the question of the RTOS. Daniel, since you mentioned the importance of using RTOS in the embedded systems nowadays, I'd like to ask, what is your take on the ecosystem kind of question around Linux right now kind of being ubiquitous and being the kernel for most applications that use processing kind of thing? What do you think will happen with embedded? It's going to converge towards a single one? What do you see that? And another question, what do you think of Zephyr?
Oh, man. I'll take the first one first.
Yeah.
I think two things are going to happen. First, the chipset providers are going to make embedded products that are friendly for real-time operating systems. We've done that on that chip I was holding up. It's really built with expanded memory at its core. There's actually no NVM. There's a little bit of ROM, but there's really no flash or RAM on the chip. It's really built to be able to scale up and down as much or as little as you need it off chip. That's a huge step for an embedded product to build, for external memory first, for the processor, not necessarily for the wireless even. So you're going to start to see features coming out from the silicon providers that are thinking about, well, what does an operating system kind of product look like, and build that. So you'll see more and more of that going forward. Secondly, I think that Linux is going to try to come down also. So the big base is bare metal, okay? So the RTOSs and Linux are going to take share from both of those. But if you go talk to ARM or to somebody who's like thinking, well, how low can A-class get? It can be lower class than it is today. How high should M-class go and how low should A-class go? And then where does RISC-V even intersect all this stuff? I think there's still going to be kind of, that story's not done. And that takes time to play out, and we're just a customer of ARM, and we're part of the ecosystem. We can't necessarily drive that. What I can say is you can do a heck of a lot more with M-class processors than you think once you have some kind of core compute engine and the memory system built for it. And so that is our strategy today. We're not doing A-class processors. As far as running Linux on a door window sensor, probably not, ever. Could you run Linux on a power tool? Probably not. Could you run it on a refrigerator? Maybe. So at some point it makes sense. And Zephyr. I'm for any OS at the moment. Let me just put it that way. The faster our customers build code, the more we all ship. And the more we ship, the more money we make. And we need to make money. Any OS is great. I like Zephyr a lot because I think it was envisioned for an IoT world. And a lot of the OSs were built prior to that model. And so they're adapting into it, but they're starting from kind of a more air-gapped state of mind. But Zephyr's not perfect either, okay? It is a little heavy for certain applications and a little hard to work with and get started. But talk to the Zephyr talk later today, how they're going to fix that. We support both, FreeRTOS, Zephyr, Micrium, and anything that our customers need. But I wish the ecosystem would just pick one.
Yes.
My goodness. No chip company wants, unless you're picking ours, we don't have one, but no chip company wants to be supporting 10, 15, 20. The zoo of RTOS is out there. Just y'all pick one, and we'll build for it together.
Thank you.
Okay, I believe I share your feelings that we would like to continue the discussion. Nevertheless, we are running out of time. Thanks a lot for your presentation, for the keynote, for the open discussion here. Very much appreciated for taking your time, for supporting the event, and for driving things forward. And looking forward to seeing you in Nuremberg in March 25.
And then Anaheim later the year.
And in Anaheim in November 25, of course. And in Shanghai in June 25. Let's conclude on this session. Let me invite you to the technical sessions in Ballroom B together with our community partners from Bluetooth Special Interest Group, from MIPI in Ballroom C, from TinyML Foundation in Room 5 upstairs. Thank you very much again, and looking forward to see you wherever, whenever.
Thank you all. Appreciate it.